Hello. In today's feature, we'll be looking at the world of mathematics, but mathematics like you've never seen before. Spare some of your imagination. It's time to delve deeper and further into the world of the deeper and further yet. Patterns, shapes, geometry, frequencies, colors, dimensions. Today, you will see familiar matters take unfamiliar shapes. Today, you will learn about the fractal universe. In our world, certain shapes have very peculiar properties. Each part of the object you're looking at is similar to itself, only smaller. These are called fractals. They differ from the smooth geometry we know, such as lines or circles. Fractals are a type of rough geometry, run by a simple equation. This kind of geometry is omnipresent in nature. The key idea in fractals is self-similarity. Let's say that it's a reflection of a reflection, indefinitely repeating itself. Here, we are measuring the patterns created by light waves using nano-optic techniques. We can see a glass needle measuring the color and the intensity of the light waves. Colors have different light waves just like frequencies have different sound waves. In this particular experiment, however, fractals determine the shape of the light wave. Fractals and their visual representation have been the source of an ongoing debate between science and art. A simple equation creating such a complex construction of shapes. Let's look at one of my favorites, the Mandelbrot set. It thrills me to see how challenging and transcending the Mandelbrot set is, visually and conceptually. No matter how much we magnify it, 1 billion times from its original set, new patterns and images will still emerge because the frontiers of the Mandelbrot set are infinitely complex.
Art, science, education. Everything else is buying and selling or something. But the only two really investigative areas of existence are in art and in science.
They're quite different, particularly in their approaches to how they, I guess, analyze the world. I mean, an artistic analysis of the world would be concerned not only with aesthetics, but primarily with the aesthetics of a situation, either visual aesthetics or in some other way. But a scientific analysis of the world really depends primarily on what can be measured about the world. So not solely how you interpret it as a person, but how anyone could interpret it.
Is that it's sort of the same idea, the same thing, the same urge to contemplate the world around you. So when people see these disciplines as different, I think it's because they misunderstand what is going on.
And many people worry about science taking away the mystery of life, about unweaving the rainbow. I think that's Blake, isn't it? I mean, it's the title of Richard Dawkins' book. I mean, Blake said that Newton unwove the rainbow. Isn't that a terrible thing? The idea being that once you realise that the rainbow is just light coming from the sun and refracting off the back of raindrops, then it's kind of not so interesting anymore. I think that's completely the wrong way around.
Renaissance scientists wouldn't even think of this, right, as different disciplines. Leonardo da Vinci is the prime example, because I don't think if you asked him, are you a scientist who do paintings, or are you a painter who also do science, he would have thought that was ridiculous. He was a human being contemplating the world around him.
Some people say that an equation can be beautiful, can have an aesthetic meaning, without any pattern representation, or that a mathematical or a physical theory can have a beauty in itself because it's an elegant description of the universe.
So there are certainly some people here who appreciate that we could all benefit from sort of cross-lateral thinking. And it's not just the entertainment, right? It is a matter about creation. We're creating our ideas.
Now, this was an open discussion, and so we explored what the boundaries were between these things. So that was number one, the issue of whether science could be art, and whether art, in fact, could be science.
Thinking about why we're here, what it all is like, why are there fractals, these kind of questions. Not how can we increase the UK's competitiveness. And that's the same in art, I would imagine. It starts with trying to express feelings, trying to understand what is a human being. That's why we make portraits, right? How do you capture?
I think it enhances the beauty of art. I don't think it undermines it. I think it multiplies it. I think it's much more beautiful when you understand the nature of what you're looking at.
It is not easy to describe the Mandelbrot set. Infinite precision in its endless magnification. The Mandelbrot set is a fractal shape run by a simple equation. When looking at its boundaries, we see scores of newly born Mandelbrot sets. And this goes on forever. Somehow, it feels like the geometry of our subconscious. The more we look at it, the more familiar it becomes. The Mandelbrot set is indeed an astonishing discovery. Some have even called it the thumbprint of God. But is the Mandelbrot set a pure scientific creation? Or has it always been around us, rooted deep within evolution?